Welcome to the online engineering drawing lessons. It's a continuation of the previous one. Now we are going to discuss dimensioning the topic. So in this dimensioning we may learn after completion of this topic that we can call it as an objective. So these objectives are namely need and importance of dimensioning in engineering drawing, standard for dimensioning, elements of dimensioning, use and specifications of arrowheads. So these are the objectives which we learn in this topic, dimensioning. Now, dimensioning definition. Dimensioning is the art of representing the various dimensions of particular drawing as per engineering norms.
Dimensioning. Representation of a single dimension include dimension line, extension lines, outline and the dimension. Two extension lines are to be extended perpendicular to the outline. The extension line should extend the dimension line by 2 mm. All the dimensions are to be neatly represented.
Need ISI code in dimensioning is ISI Indian Standard Institution has recommended IS 696 in 1972 Code of Practice for General Engineering Drawing. Later it has modified the standards to suit the International Exchange of Drawings, which are included in ISO 129 in 1985. As such, the Bureau of Indian Standards, latest name of ISI, introduced a new code with SP 46 1988 in March 1989, titled as Engineering Drawing Practice for Schools and Colleges. Elements of dimensioning. In these elements of dimensioning, dimensions are indicated on the drawing to define geometric characteristics such as length, breadth, height, diameter, radius, angle, location of holes, slots, features, etc. Elements of dimensioning as that is extension lines, these are the elements of dimensioning, that is
Dimension line is one which is parallel to the outline. Leader line is one which will indicate any specific information about a particular entity. The leader line will also contain a note. Arrowheads are to be drawn with a specification of 1:3. The dimension line should contain 2 arrowheads which will terminate the dimension. The extension lines are perpendicular to the outline.
Extension lines is a short line drawn perpendicular to an outline. It extends 2 millimeters beyond the dimension line. They are drawn between 2 extension lines parallel to outline. There must be only one dimension line between any 2 extension lines. Leader line. These are the lines referred to future or not. They are drawn at suitable angles, preferably 30 degrees, 45 degrees or 60 degrees. They should never be drawn horizontal or vertical. Arrowheads. The common types of arrowheads recommended by BIS as given below. That is open 90 degrees, open 30 degrees, closed blank, closed filled, oblique arrowheads. Normally the arrowhead proportion is length equal to 3 times the width, that is 1:3. Please note down. This is the arrowhead proportionate. Now in this we have learn need and importance of dimensioning in engineering drawing, standard for dimensioning, elements of dimensioning, use and specifications of arrowheads. Now we learn how to add the quiz questions. Number 1. As per BIS, the latest code to be used for engineering drawing practice is A. SP 46 in 1988, IS 696 in 1972, none of the above, and both of A and B. The answer is as per BIS, latest code to be used engineering drawing practice is SP 46 1988. Now second question, the line is used to convey any specific information is A. dimension line, B. leader line, outline, none of the above. Answer is leader line. True or false? Extension lines are perpendicular to outlines. Is this true or false? True. Now next, so some of the frequently asked questions are also there. You may note down with the previous data. Now the next topic is surface finish. This surface finish, in this we learn surface finish, indication of surface textures. So you remember the previous one and what we have discussed just now. So after completion of this surface finish, we are learn need and importance of surface finish in engineering drawing, indication of different surface textures using symbols, specifications of surface texture. Now with this, we are already learned the need and importance of dimensioning in engineering drawing, standard for dimensioning, elements of dimensioning, use and specifications of arrowheads. So with this background, now we are little bit move to surface finish chapter with these objectives. Indication of surface finish. An engineering component may be cast, forged, drawn, welded or sampled, etc. All the surfaces may not have functional requirements and need not be equally finished. Some surfaces, owing to their functional requirements, need additional machining that needs to be recorded on the drawing. Surface texture is the variation in surface including roughness, waviness, lay and flace. Roughness describes the finest irregularities in the surface. Please note down the information. Indication of surface textures. That is, basic symbol consists of two legs of unequal length indicated at approximately 60 inches to the line representing the described surface. As shown, please note that if removal of material by machining is required, a bar is added to basic symbol like this. If the removal of material is not permitted, circle is added to the basic symbol like this. When a special surface characteristics have to be indicated, a line is added to the longer arm of any of the above symbol. The value or values defining the principal criterion of roughness are added to the symbols like this. Please note down. A is the surface roughness. It is necessary to impose maximum and minimum limits of the principal criterion of surface roughness. Both values shall be shown like this, A1, A2. If this indicates minimum and maximum criteria, that is maximum limit is A1 and the minimum limit is A2. The specifications of surface texture shall be placed relative to symbol as shown in this figure. Note down where A is the roughness value of RA in micrometers or roughness grade number N1 to N12. B, production method, treatment or costing. C is sampling, length, D, direction of lay, E, machining allowance, F, other roughness values in brackets. So like this, the values are indicated as shown. Please note on this table. representation I'm drawing. Now done. This is a little example. Now with this we are studied like need and importance of surface finish in engineering drawing, indication of different surface textures using the symbols, specifications of surface texture. Now you can able to note down the quiz questions with this background. Number 1. Finest irregularities in surface is described by A. Waviness, B. Fly, C. Roughness, D. None of the above. In this answer is roughness. Symbol for removal of material by machining is A, B, C, and the answer is B. Now third question. The surface textures specification letter E indicates A. Sample length, B. Machining allowance, C. Direction of clay, none of the above. Answer is B. That is machining allowance. Now note down some of frequently asked questions. There is examination questions. Please note down. Now with this we will move to the next topic, that is placing of dimensions. Placing of dimensioning. So with this, before going to start placing of dimensioning, so recap the previous what we have discussed. That is need and importance of surface finishing in engineering drawing, indication of different surface textures using symbols, specifications of surface texture. So this is with this background we are move to placing of dimensioning. So in this you may learn that is aligned system of dimensioning and its rules, and unidirectional system of dimensioning and its rules. So after completion of this placing of dimensioning, we will ready to do the placing of dimensionings. Now first one, aligned system. In the aligned system, the dimensions are written centrally above the dimension line that has no break. Horizontal and inclined dimensions can be read from the bottom of the drawing. The vertical dimensions can read from right hand side of the drawing. Please note down, this type of aligned system is named as aligned system. Note down the figure. Unidirectional system. In the unidirectional system, dimensions are always written vertically in the space left within the dimension line. All dimensions can read from bottom of the drawing. Please note down for this unidirectional system. Now we are studied in this meaning of dimensioning, placing, and rules are to be adopted in aligned and unidirectional dimensioning methods. Now we are see some of the quiz questions, that is true or false. In aligned system of dimensioning, horizontal and inclined dimensioning are to be read from bottom. Means it's correct. That is, in aligned system, you may read the dimension horizontal and inclined dimensions are to be read from bottom. That is true. And next, in unidirectional system, all dimensions can read from the bottom. Yes, it is also true. Please note down the questions. Now we are going to ask from this topic, that is mention the two basic systems of dimensioning. What is unidirectional dimensioning? We may ask like this questions in examination point of view. Note on this. And the next topic is arrangement of dimensions. So in this chapter, we may learn the objectives or completion of this period. This topic, you would be able to know the concept of chain, parallel and combined dimensioning and their rules. General rules to be strictly adopted in dimensioning. So with this basic objectives, you may learn in this topic arrangement of dimensioning. Arrangement of dimensionings or continuous or chain dimensioning. In this dimensioning from future to future is known as chain dimensioning. Tolerance can accumulate, making the end product larger or smaller than expected. It has possible consequences in a manufacturing part. Now,
continuous or chain dimensioning. In this, let us see about how to represent dimensions using chain or continuous dimensioning method. In this method, all the dimensions are represented continuously one after the other.
See, observe how is there.
Parallel dimensioning. In this, let us see how to represent dimensions using parallel dimensioning method. In this method, all the dimensions are represented with respect to a common origin. Care should be taken in such a way that the distance between two dimension lines is at least 10 millimeters. Parallel dimensioning. In this, let us see how to represent dimensions using parallel dimensioning method. In this method, all the dimensions are represented with respect to a common origin. Care should be taken in such a way that the distance between two dimension lines is at least 10 mm. Combined dimensioning. Both the methods of chain dimensioning as well as parallel dimensioning are used to conveniently represent the dimensions.
Now progressive dimensioning. This method is used where parallel dimensioning is not practicable due to space constraints. In this method, all the dimensions are represented sequentially with respect to common datum, that is origin, with the arrowhead only in forward direction. It is method of superimposed running of dimension. Please note down this example. Now next one is coordinating dimensioning. It is a method of dimensioning in which coordinate table is used to represent the coordinate positions and sizes of different entities of drawing. It makes drawing is easier to read when the part has many dimensions. Example, consider a plate with many holes as shown in below. That the size and the coordinate position of various holes can be conveniently So note on this. The sizes and coordinate positions of various holes can be conveniently represented in a table form as shown in below. Now dimensioning rules. A gap at least 10 mm should be provided between outline of drawing and dimension line. Unidirectional representation of dimensions should be adapted. In case of vertical and inclined dimensions, insert the dimension vertical stroke in the middle by breaking the dimension line. In case of horizontal dimension, keep dimension centrally above the dimension line. All dimensions are to be represented. No dimension should be repeated. Chain or parallel type of dimensioning can adapted. As far as possible, dimensions are to be shown externally. Now with this, we are read some how to give the quiz questions. Now first one, dimensions from feature to feature is called parallel dimensioning, chain dimensioning, progressive dimensioning, none of the above. This is answer is chain dimensioning. In child dimensioning, all dimensions originate from common point. It is true or false means it is false. In dimensioning, same dimension should not be repeated. Yes, it is true. So like this, we will give some true or false questions and quiz questions. Now, note down the frequently asked questions. What are the basic rules of dimensioning? Differentiate between chain and parallel dimensioning. So with this, we will move to another topic, is rules for dimensioning standard features. So in this topic, we are going to learn dimensions of circles, arcs, chords, dimensioning of angles, dimensioning of spherical, square objects, dimensioning of chamfers, counters, strings, and tapers. So first one is rules for dimensioning standard features. Circle should be dimensioned by one of the method as shown below. Dimensioning of circle is to be placed properly to ensure clarity. So with this, we learn some
dimensioning of circles. In this, let us see about how to conveniently represent the dimension of a circle. Dimensioning a small circle with arrowheads inside will lead to confusion. Dimensioning a small circle with outside arrowheads will be clear and readable. Dimensioning a medium-sized circle with arrowheads inside looks to be good rather than marking it outside. Dimensioning within the circle will increase the total drawing clarity rather making outside for larger circle. Dimensioning diameter. If more diameters are to be represented, and if all such diameters are represented in a single view, it will be confusing and complicated. Instead, the dimensions should be placed on the most appropriate view to ensure clarity.
Arc dimension is identified by like this, placed above the value is like this, and dimension sphere is like this. The radius or diameter of sphere surface should be represented by the letter S, which indicates sphere. Dimensioning of chamfers. Please round on all. Dimensioning of angles. Dimensioning of sphere. Squares and hexagons. Dimension of square should be represented by symbol square. The dimension of hexagon should be represented by word hex. Dimensioning square and hexagons as given. Dimensioning chamfers like this. So note down. chain type or parallel type dimensioning can be adopted. Here, tapers by giving two diameters and perpendicular distance between them as noted. By giving one of the diameter distance between the end faces, that is length of taper, and taper using conical taper symbol. The taper is calculated by taking the ratio of difference between diameter of end face and the length of taper. Note on this figure, conical taper symbol. Taper 1/5. By giving one of the diameter, length of taper and taper angle. Representation of narrow dimensioning. So note down all. In case of narrow dimensioning, depending upon the space available, the arrowheads and dimensions can be placed inside or outside. If the space is too narrow, they may be placed conveniently outside also, like right side. Now, in this we are studied the dimensioning of circles, arcs, chords, dimensioning of angles, dimensioning of spherical, square objects, dimensioning of chamfers, countersinks, and tapers. So with this, we give some quiz questions like number 1, dimensioning S545 refers to a spherical object, that is S is used for spherical object. Here square object and none of the above are both of A and B. So it is answer is spherical object. Dimension rectangle 20 represents the side of square, dia of circle, radius of sphere. So here it will represent the side of square. Now, in case of circles, the radius should be represented. Is it true or false? Means it is false. Now, some of the frequently asked questions. Now done. Now we are going to learn one example in this next topic. A dimensioning of circles we have already studied, arcs and chords, dimensioning of angles, dimensioning of spherical, square objects, dimensioning of chamfers, countersinks, and tapers. So with this background, we are see one example. That is, draw the figure and write correct way of dimensioning.
Dimensioning practice. The given view contains dimensions represented wrongly. The view is to be neatly redrawn, and all the dimensions are to be neatly represented as per the norms. The dimensions are to be represented outside the view. Clear distance should be provided between the outline and dimension line. The dimensions are to be neatly represented appropriately.
Now identify with red indications, that is cross indications or wrong indications. Now with this, we will give some true or false questions. Dimensions are to be shown externally as far as possible. Yes, it is true. In case of circles, the diameter should be represented a prefix phi. Yes, it is correct. And the center lines or axis must be extended well being the drawing. Yes, it is true. And with this, we may learn some previous questions. So note down with this. That is, draw the figure and write correct way of dimensioning. Now we learn some more examples. That is example number 2 with the previous background. So note down the figure, redraw the figure and write correct way of dimensioning. So this explanation will be seen now.
Example 2. The dimensions are to be printed neatly as per the norm. All the dimensions are to be shown externally. Represent the dimensions in an aligned manner. Keep the symbol for diameter prior to the numerical value.
Here one of the true or false question. The same dimension should not be repeated. Yes, it is true. See some frequently asked questions. You note down all these because these are all examination point of view questions. Redraw the figure and write correct way of representation, dimensioning. And now we will see another example, that is example 3.
Example problem 3. In this, a view with the wrong representation of dimensions is available, and the task is to redraw the view and to neatly represent the dimensions as per aligned system. The dimensions are to be printed neatly as per the norm. All the dimensions are to be shown externally. Represent the dimensions in an aligned manner.
Now identify what are the wrongs are available in the given figure. Now after redrawing,
keep the symbol for diameter prior to the numerical value.
the dimension line should not be start from on outline. Yes, it is true. Now you note down the frequently asked questions. In a aligned system, now with this we will close here and we will continue next lesson with some more examples.